Section 11.4 is about geometric series. We've already learned about geometric sequences, and a series is when you add up or sum the terms in a geometric sequence. Here are some examples of sequences, and if you add those terms up, then they become a geometric series. There are some formulas for the sum of geometric series. There's actually two versions of the formula, this one and this one. You can see things that we've talked about in the past. A sub 1 is the first term. R is that common ratio. Notice that R cannot equal 1. You can't use geometric series in which R is a 1 because then you would be dividing by 0. In this example, we're told that in the book Roots, Alex Haley traces his family history back a number of generations. And then it asks us if we could trace our family back for 15 generations, starting with our parents, how many ancestors would there be? So it's an interesting question. Well, if we're going to do this, we're going to need to use the formula. We have to find out what the first term is. We have to find out what a sub 1 is. We have to find out what the common ratio is. And then we also need to know what term we're looking for. Well, we're going to go back 15 generations, so we know n is going to be 15. Now, finding the first term, if you think about it, the first term is going to be 2 because you have two parents. And then each one of those parents has a set of parents, so then that's going to be 4. So then the third term is going to be 8. So this is actually the sequence that we're looking at, 2, 4, 8, 16, and so on. So we know that a sub 1 is going to be a 2. And now what about the ratio? If I take each value and divide by the one in front of it, you can see that to get from 2 to 4, you multiply by 2. To get from 4 to 8, you multiply by 2. So the common ratio here is a 2. Now with those three pieces of information, I can use my formula for a geometric series. So here's the formula, and I know that 15 is my n value, the value that I'm looking for. And my a sub 1, my first term is 2. So 1 minus the ratio of 2 to the 15th power all over 1 minus 2. And now we can solve this. Now if you put all this in a calculator, you find that the 15th generation will have had 65,534 ancestors. Here we're asked to evaluate a series. This Greek letter here is sigma. So this geometric sequence is written in sigma notation. And I can evaluate it in one of two ways. I can just do it by hand or use the formula. I'm going to start by hand just to show you what we're doing. So I'm going to take n of 1 and plug that into the top. And I'm going to add that to the next one, which is 5 times 2 to the 2 minus 1. So I increase n by 1. So if I keep increasing n by 1, I get these 6 values that I'm going to add together, 5, 10, 20, 40, 80, and 160, for a total of 315. Now that can take a long time and be fairly tedious. So the other way to find this series is to use the formula. So since I have 6 values altogether, I'm going to use s sub 6. I'm going to take my a sub 1, which is 5. 1 minus the common ratio. In this case, the common ratio is right here. It's the 2 to the 6th power, and that's 1 minus the common ratio again of 2. So this is going to be 5 times negative 63, because it's 1 minus 64 over negative 1. And if you put that in a calculator, you get 315 again. In this example, we're going to find the sum of the series again, the geometric series. But this time we're given an a sub n. And when that's the case, we're going to use the alternate form, the other version of the formula. Looks like this, and we'll plug the values in. A sub 1 is 15,625 minus a sub n, we're told, is negative 5 times the ratio of negative 1/5. And that's all over 1 plus 1/5, because minus a negative is going to be a plus. So this is all really going to be a 1, and it's 15,624 then when you subtract 1 from that. And we'll divide that by 6/5. You can multiply by the reciprocal or use a calculator, and you're going to get 13,020. So my series adds up to that value. In this final example, we know some information and we're trying to find a sub 1. So we'll use the alternate form. Because I know the sum of the first 8 terms, I know s sub 8, then I'm going to find a sub 1 by using an 8 for my n value. And then I can also probably plug right in 3 for the r's. And then because I know that s sub 8 is 39,360, I can plug all those values in. And now we'll try to solve for the a sub 1. So multiplying the top, negative 6560, so we'll multiply both sides by negative 2 and then divide by 6,560 negative. So you can do all that work and you find out that a sub 1 is 12. So the first term in this geometric series is 12.